about the fundamental particles of an atom, right? Their position and charge. We know that the fundamental particles are proton, electron and neutron. We have a table here. Let's complete the table. In the first column, we have the name of particles. Again, we know that particles are proton, electron and neutron. In the second column, we have position of particles. In the atom, proton and neutron are situated in the nucleus and electron can be seen outside the nucleus. In the third column, we have mass of the particles. The mass given are used for practical purposes. What is the mass of proton? And what about the mass of neutron? From the table, it is clear that proton and neutron have 1 unit mass. Then, mass of electron is very less and we can take it as 0. From the table, it is also clear that masses of proton and neutron are mainly responsible for the mass of an atom. From the table, it is also clear that masses of proton and neutron are mainly responsible for the mass of an atom. We already know that, right? Then, I will ask you a question. What will be the mass of an atom having only 1 proton and 1 neutron? We know that 1 proton has 1 unit mass and 1 neutron has 1 unit mass. Therefore, the total mass of the atom is equal to the sum of masses of proton and neutron. So, we get 2 unit mass. I hope it is clear to you. If it is clear, then tell me what is the mass of an atom having 2 protons and 2 neutrons? 2 protons have 2 unit mass. 2 neutrons have 2 unit mass. So, the total mass of the atom is equal to mass of 2 protons plus mass of 2 neutrons. That is equal to 2 unit plus 2 unit. That is equal to 4 unit. So, the total mass is 4 unit. Now, we take the total mass of protons and neutrons. What about the total number of protons and neutrons? If we take the total number of protons and neutrons, we get a number that is called mass number. That is called mass number. So, what is mass number? The total number of protons and neutrons in an atom is called mass number, and this mass number is represented by capital letter A. So, we just saw what is mass number. Then, tell me which is the fundamental particle of an atom that can be displaced when atoms rub against each other or they undergo chemical reaction with other atoms? Electrons, right? What is the reason? Because it is present outside the nucleus. We know that protons in an atom do not undergo any change in any situation. Hence, the number of proton in an atom is very significant. Therefore, an atom is identified by the number of protons in it. We can say that it is like an identity card for an atom. If we take the total number of protons in an atom, it is called atomic number. Another term. What is atomic number? The total number of protons in an atom is called its atomic number. We know that mass number is represented by capital letter A. So, the atomic number is represented by capital letter Z. Since atoms are neutral, the number of protons in an atom is equal to number of electrons. We can say that atomic number is equal to number of protons, or it is equal to number of electrons. Why? The number of protons and electrons in an atom are equal. So, we discussed about atomic number and mass number. Imagine if we have mass number and number of protons, then how will we find out the number of neutrons? I will tell you. If we have mass number and number of protons, then number of neutrons is equal to mass number minus number of protons. We know that number of protons is atomic number. So, the equation becomes mass number minus atomic number. That is, number of neutrons is equal to mass number minus atomic number. We learned about symbols of elements last year, right? Now, we are going to include the mass number and atomic number to the symbol of an atom. Are you ready? It will help us to infer more details about the atom. Here, we have symbol of sodium. We know that sodium gets its symbol from Latin word natrium. Then, look into the symbol of sodium. You can see two numbers. One is at the top left side of the symbol and other is on the bottom left side of the symbol. The number on the top left side is mass number. The number on the top left side is mass number and the number on the bottom left side is atomic number. Therefore, we can say that the mass number of sodium is 23 and the atomic number of sodium is 11. Okay. Now, we have a table here. We have the symbols of some elements and we are going to calculate the number of protons, electrons and neutrons. Are you ready? Okay. Let's take first element. Which is that? Yes, hydrogen. What is the atomic number and mass number of hydrogen? Mass number is on the top left side and the atomic number is on the bottom left side. So, for hydrogen atom, mass number is equal to 1, atomic number is equal to 1. Therefore, the number of proton is equal to number of electron is equal to 1. Why? Because we know that in an atom, number of proton is equal to number of electron. Now, we can calculate the number of neutrons, isn't it? How we calculate the number of neutrons? Yes, mass number minus atomic number. We know that mass number is 1 and the atomic number is 1. So, the number of neutron is equal to 1 minus 1, that is equal to 0. Then, the next element we have helium. What is the mass number and atomic number of helium? Yes, the mass number of helium is 4 and the atomic number is 2. Then, what about the number of proton? Yes, atomic number is equal to number of proton. That is, number of proton is equal to 2. That is equal to number of electron and it is also 2. Then, what about the number of neutron? Yes, mass number minus atomic number. Here mass number 4, atomic number 2. Therefore, the number of neutrons is equal to 4 minus 2, that is 2. So, helium have 2 neutrons. Then, the next element is lithium. What about the atomic number and mass number of lithium? Mass number of lithium is 7 and the atomic number is 3. Again, the number of protons is equal to number of electrons is equal to 3. Then, what about the number of neutrons? Yes, 7 minus 3, that is equal to 4. Okay. Then, we take magnesium. Then, magnesium, the mass number is 24 and the atomic number is 12 and the number of protons is equal to number of electrons is equal to 12. Then number of neutron, that is 24 minus 12, it is 12. So, magnesium have 12 neutrons. Then calcium. What is the atomic number of calcium? 20. Mass number 40. So, the number of protons is equal to number of electrons is equal to 20. Then what about the number of neutrons? Yes, 40 minus 20. That is mass number minus atomic number and we get 20. So, calcium has 20 neutrons. Like this, we can find out the number of fundamental particles of these elements. Okay, is it clear for you? So, in this we learned about fundamental particles, mass number and atomic number. Now we know how to calculate the fundamental particles of an atom. We have a lot more to discuss about atom and it will discuss later. Bye.
Enclaps.